So, okay, good morning and good afternoon, ladies and gentlemen, and welcome to this third day of the Middle East HSE Sustainability Week conference. And this morning we have the pleasure of having an opening keynote from His Excellency Sheikh Mohammed bin Khalifa Al Khalifa, the Minister of Oil. Ministry of Oil in the Kingdom of Bahrain. He was appointed as the Minister of Oil under the Royal Decree number 45 issued by His Majesty the King Hamad bin Isa Al Khalifa, King of Bahrain, in 2016, and was reappointed under the Royal Decree number 61 in 2018. Sheikh Mohammed started his career in the Ministry of Finance, Kingdom of Bahrain, in 1999, where he became Director of Government Shareholdings in 2005. During his tenure at the ministry, he worked also on key projects, including the privatization of power plants, SEEF properties, IPO, and the Muharraq STP. In 2011-2016, he was the Chief Executive of the Oil and Gas Holding Company, steering business and investment activities of the oil and gas sector. I believe that organization was called NOGA. He was the former chairman of the NOGA, the Oil and Gas Holding Company of Bahrain Petroleum Company and Tatweer Petroleum Company as well. He was also a former board member in the Central Bank of Bahrain, the Bahrain National Gas Expansion Company, and the Lulu Tourism Company, and he's currently the chairman of the Arab Shipbuilding and Repair Yard Company. So Sheikh Mohammed has graduated with honors from the King Fahd University of Petroleum Minerals with a BSc degree. He completed his higher education in the United Kingdom with a master's degree from the University of Cambridge and an advanced master's from the Imperial College of Science. He also holds an MBA from the DePaul University Kalistad Graduate School of Business, and I've had the pleasure of meeting Sheikh Mohammed actually several times, and His Excellency has always impressed me with his not only his knowledge and wisdom, but also, mashallah, his humility. So again, Your Excellency, it is a pleasure to have you here with us at this Energy Institute event, and it's a pleasure for me personally to have you on this. So I'll hand over to you now for your keynote, sir. Thank you.
Well, the pleasure is mine, Dr. Allah. Thank you very much for that intro. Bismillah ar-Rahman ar-Rahim. Sa'adallah sabahkum. A very good morning, good afternoon to you all. I'd like to thank the Energy Institute for inviting us on this third day. So I'll set the scene by talking about 5 of the relevant sustainability development goals of the United Nations. And let's talk about how they impact our industry. And with COVID, probably the best to start with is SDG number 3, good health and well-being. We were all impacted in our industries with lockdowns, and it's an extreme challenge when you have operating environments like refineries, oil fields, chemical plants, logistics. All of those prove to be a real challenge. But a bigger challenge is when you have an ongoing mega project like we did with the Babco expansion. Now, kudos to the management. The first thing that happened was that all our group companies collaborated as one. So they exchanged knowledge, which meant that they were quick to adapt to changes as they had come. This hit us hard early last year, and nobody was really prepared. But I have to commend the efforts that were made in Bahrain and in the region. The level of collaboration we saw is second to none. And with that, we never had a day of disruption in operation, nor did we have a day of disruption in the construction of Babco's mega project. And this was with the influx of thousands of workers, and we had to make sure that the virus infection rates had to be controlled, and they were controlled very effectively together with government policies. And as you know, the GCC had full collaboration when it came to the healthcare side of things. So all those policies were distributed very quickly. There was a very steep learning curve, all due to the integration, and technology came to the rescue. I think virtual meetings were extremely important to have helped with that. And of course, ultimately, it's the medical staff and the miracles they did is the real reason that we avoided the worst of this. And hopefully, we're approaching, the end. Let's hope this new wave does not propagate across the globe again. But it seems that we've adapted quite well. So SDG number 3, good health and well-being, absolutely critical. And now we see it with a different perspective with what really happened last year and this year as well. The second one is something that everybody's talking about, and it's SDG number 5, that's gender equality. We just had an event that has been going on for more than 7 years now, and it's LEWAS, the Leadership Excellence Award for women in the industry. And we've seen a lot of winners from all over the GCC. I think one of the top awards went to a lady from ADNOC this year, and many other winners as well that really show the impact that women have had on growing organizations. And ultimately, this is all towards the real goals of gender equality. Then we move on to SDG number 6, clean water and sanitation. Well, sanitation, we all have these sanitizers now walking around. We have never been cleaner, I think, in the history of the world in the past 2 years. But water in this part of the world is really expensive, and people sometimes don't realize it. It costs us a lot of money to desalinate water. The reliance on desalination here is very highly concentrated. And one of the things we have done here in Bahrain, together with the government setup of what's called a Water Resource Committee, we collaborated with the Green Climate Change Fund, which was an offshoot of the framework agreement of the climate change out of the United Nations. It was set up a few years ago after the COP21 in Paris. And the fund was established in Korea. And the idea is to help developing nations avoid the high emissions of greenhouse gases as they move on to the development cycle. And what we ask them to help us with is to really look at ways of combating the scarce water resources. Climate change impacts seawater level. Seawater level here, especially with coastal areas in the Gulf, affects how the aquifers are managed. As seawater levels rise, they infiltrate the aquifers. And we have been studying that here in Bahrain. And we've been looking at various ways to make sure we arrest that encroachment of seawater into the freshwater table. Now, the way the Arabian Peninsula is done is you've got the high mountains of the western Saudi Arabia called the Arabian Shield. And typically water propagates underground all the way to the coast. And Bahrain, of course, is linked to the very large underground aquifer called the Dammam aquifer. And this is why Bahrain has the current name, Bahrain. You still have freshwater springs in the middle of the sea, and hence the term 2 seas or Bahrain. Now, if we're not careful, eventually the salinity of these aquifers are going to rise until they become equivalent to seawater level. So we've been looking at various ways to maintain those. We also discovered that we have deeper zones as we drill towards oil that have fairly low salinity water that would cost you much less to desalinate. And hence now the real emphasis is on the true cost of water here, and probably is one of the most expensive sources of water because of the intensive use of energy for desalination. A very important subject for us here in the Gulf to make sure that we understand where the costs of desalination are going and how to make sure that we can create new sustainable sources of water other than seawater desalination. The 7th would be affordable and clean energy. Now, affordable energy, my take is that there is no real alternative to hydrocarbons. And hydrocarbons are now hit with the with the headwinds of the climate change agenda. A lot of the banks, a lot of the financial institutions, the government export credit agencies, the UK and other European countries have now decided to stop funding upstream projects. Now, you do this too early, and we've just been through a 7-year low price cycle and low investment cycle, where more than $1 trillion have been wiped out of the investment in conventional oil and gas. Supply is going to soon be a challenge. We are not transitioning away from oil or gas anytime soon. Yes, we're calling it a transition fuel, but is it 100 years? Is it 50 years? It can't be less than that. And the challenge the world is facing today is that energy is going to become very expensive, and hence the challenge of affordable energy. What's the alternative? The real scalable alternative is not yet there. Now, on the other side, we're trying to also develop clean energy. But hydrocarbons themselves are not the culprit. The culprit is emissions. So what do we need to do with emissions, carbon sequestration, etc.? And if you look at the Gulf, and I looked at the study with Bahrain. This is not an official study, but I found it on a third-party website. And they claim that 80% of our carbon footprint, we're yet to confirm that, comes from burning gas for power and desalination. So if it's true for the Gulf, and the majority of your carbon emissions really come from power stations and desalination, and if we move towards hydrogen burning rather than methane burning, then that takes care of more than 50–60% of your ultimate net zero compliance. Now, the challenge with that is the technology is not yet ripe. Burning hydrogen in power turbines is 3 times less efficient today than it is methane because of the way the concentration of hydrogen, it's not as concentrated as methane. So you need 3 times the volume to achieve the same calorific value in terms of electricity generation. So that is work in progress with many of the turbine manufacturers, but it's still in early stages of development. But once that is done, that would give us a true path to achieving a huge amount of reduction in carbon emissions. Now, the US did it without design. They just did it because shale oil was there, and shale gas was produced at very cheap rates, and it replaced a lot of the coal power generation. And hence, the US was one of the few countries that achieved a huge reduction in carbon emissions towards clean energy. And third, of course, and the last is climate action, which is very much linked to what I just talked about. But ultimately and fundamentally, we have to make sure that when we approach these projects, we make them economically feasible. You don't want to just go in and subsidize something a bit too early. Europe did that with solar more than a decade ago, and they were 10 years too early. Had they waited a little bit, solar power would have been more affordable. Well, they put a lot of emphasis on wind, and when wind didn't blow at the beginning of this winter, they suffered, hence had to pay prices of gas we've never heard of before. So it's very dangerous to underestimate the importance of early investments and to think that we're already in transition away from oil and gas. We're decades away from this. But in the meantime, there needs to be a lot of investments. And for there to be a lot of investments, we need to do a lot of work on making sure we also meet our targets in carbon emissions. A lot of challenges for HSE. And of course, you're moving into a boom cycle for commodities now, which means that there will be opportunity to make investments. The challenge is to make them the right investments. That's my introduction for you today. And back to you, Dr. Wadah. Happy to answer any questions you might have.
MashaAllah alayk, Allah yahfazk. Thank you, Your Excellency. I think just to reflect on what you said with regards to collaboration, I think I very much agree with you. The collaboration is probably the key in all kind of industries, and we saw actually, as you know, from the last COP in Glasgow, that it was people who were a little bit let down felt that there wasn't enough of a commitment at the end of the day for that collaboration to take place in terms of the commitment. But yes, definitely also here in the UAE, if I reflect on maybe what you said happened in Bahrain, where organizations came together and collaborated and shared and exchanged knowledge, and perhaps maybe this is in the and you closed by talking about HSE as well. So, and in the HSE space, as you know, Your Excellency, from a collaboration point of view, the oil and gas industry maybe don't collaborate as much as, say, for example, the aviation industry has collaborated in terms of addressing a lot of the kind of incidents and learning from those kind of incidents and sharing really best practice to make the oil and gas industry, or the energy industry, more holistically a high reliability organization or industry like the aviation industry. I also hear what you say about the clean water and sanitation, and yes, definitely, I think in our part of the world, as you know, Your Excellency, the link between energy and the cost of energy and water, which is the most probably the most important resource that we have, is so tightly coupled, so that energy and water, and for us the cost of water is very much more linked to that cost of energy, and finding let's just say saline waters to desalinate is obviously a great idea. Also, the fact that the impact is on the Arabian Gulf, the water salinity has been going up obviously over the past 10-20 years quite markedly. So one question maybe I pose to you with regards to, you didn't mention really SDG 17, which is on the partnerships. What would you say? What do you say about the kind of partnerships which are developing maybe in this part of the world, or what kind of partnerships do you see are going to develop, say, in the next 5 to 10 years? That's going to really try to resolve these kind of issues, probably in a post-COVID world, obviously. But I'm talking actually beyond COVID, the kind of partnerships, linking especially affordable energy to clean water and sanitization and all these kind of areas together.
Okay, well, I think there will be many collaborations on many fronts, but the more important ones would be the ones linked ultimately to investment. Whatever policies come out of institutions linked to financial institutions, whether banks or capital markets, that will dictate how projects are funded. In the past, they would look at your credit worthiness. Now they're developing environmental targets, and they will even ultimately, I'm sure, come up with, like they give you credit ratings on your financial worthiness, S&P, Moody's, or Fitch. They'll probably try to do the same with the environmental side. But once that happens, then it is linked to the physical world and the movement of money. And already I can see the challenges of investing in oil and gas. Capital is being made more restricted coming into oil and gas, and that's dangerous. One of the reasons of having high oil prices and continuing to have high oil prices is because of this policy, which ultimately will create unwanted high energy prices. Because transitioning into renewables is going to take decades. So it is not yet mature enough. It's not scalable enough. You might have a lot of electric vehicles, yes, but air travel, diesel engines, shipping lanes, they will continue using hydrocarbons. Plastics is a different industry, but when it comes to fuels, it's going to take us decades, unless there's a breakthrough in battery technology, which as of yet we haven't seen anything. The production of lithium, 3,000 tons a year, cannot even cover the amount of cars sold per annum. It's probably 6% of the total cars if you use all the lithium produced. So you are under-resourced. This is where we have to be careful. I think the most important one will be the collaboration when it comes to all the policies coming out of organizations linked to banks, whether it's Basel, European Union, in the United States, of course, whatever organizations linked to how banks ultimately fund. Basel is probably going to have an environmental component. The Bank of International Settlements, all of these organizations, to me, would carry higher importance than others because they will have a direct impact on the way business is done. The other is policies of trading. Well, and if to sell aluminum or any other product, you need to have green or blue energy. We have to be ready for that. We export a lot of aluminum from the industry, a lot of raw material. And if they need to be designated as at least blue or maybe even ultimately green, then we have to be watchful of that space because that would affect how our markets are going to change. We might not have the same markets we have today. So that's important to understand where it's heading. To me, there's a lot of gray areas now. Where are we heading? As you said, in COP26, there wasn't real clarity on what's going to happen next. But I already see it happening in some banks. Some banks have voluntarily made decisions, some large European banks, not to fund upstream projects. I know that the UKEF, the Export Credit Agency of the UK, has also decided not to fund hydrocarbon projects. The last one they funded was, I think, Babco, the one in Bahrain here as a refinery. They might do petrochemicals, but nothing upstream. So that would be what I would focus on more, but not to say that everything else is going to also be important. And at the GCC level, all the diplomatic side of things. This spans all sectors: education, health. But from my side, I'm more interested in how it affects the oil industry and particularly on funding and finance and the markets.
Yes, understandably, Excellency. But before we let you go, we're just at the time. But there is a nice question here from Sumaya. Let me read it out to you. She says. Thank you, Your Excellency, for the insightful speech. My question is, how do you see the feasibility of waste to energy as a promising renewable resource of energy to operate many facilities in a clean way, using, for example, incineration, pyrolysis of syngas production, H2 source, and AD for biodiesel, or biofuels. Recently, says I was honored by receiving the LIWAS 2021 award from His Excellency Sheikh Mohammed, which is highly appreciated. Thank you very much. So maybe a question here about, well, the waste to energy. I mean, it is a big subject, I know, sir, but perhaps your insights.
I think it's probably the only way of recycling waste, and plastic waste in particular. Now, my opinion is incineration is probably the way to go. Provided that you fully control emissions. And in Europe, they did that successfully. So you have these house waste incineration plants in the middle of Paris with zero flue gas. And what they would do is they would just have a network of hot water connecting suburbs of Paris. I think Dubai is now in the process of building its first waste to energy, if I'm not mistaken. That will be the first in the Gulf. I think that's the right way to go to deal with waste. And in Bahrain, we have a challenge with landfills because of the small area. And we have to find a solution to that kind of waste. Now, the more plastics you have, the better it is as a fuel, because you gain heat, you gain calorific value. Solid waste, food and other stuff from households does not have a lot of heat. But you need plastics to be part of that. And then you have to really control dioxins because burning them is toxic. But the technology is there to make sure you have zero emissions. Waste management is the way to go. It is better than recycling. I don't think recycling is that economic. But and this is why Europe and the UK has gone heavily towards incineration and using heat to generate electricity.
Okay, fantastic. Thank you so much, Your Excellency. We are out of time, but you know, perhaps maybe before we let you go, maybe some you know, closing remarks about you know, to the members of the Energy Institute and to these delegates who are here today, with regards to what they should be doing in the energy space. Maybe some final remarks.
Well, I think we're about to enter a high commodity price cycle, which means more opportunities to invest. Hopefully we invest in the right ideas. So this is the time to come up with the right ideas for sustainability. We need to make our industry sustainable. We need to really focus on reliability. You know, the Generation Z is not as easy to, to keep focused as previous generations. So succession is critical. And unfortunately, Wadah, you and I are not as young as we used to be. But we need to make sure that the generations that are coming, are ready to take the industry into the exact same and hopefully even better reliability. You know, we have amazing track records in the region, but that doesn't mean that we can sustain it easily. It's very challenging, especially when you haven't had any incidents for decades. Complacence sets in. But you need to make sure that you keep on training the new generation, make sure that they have the right level of discipline. Our industry is one with high risks. As you said, the airline industry is full of that collaboration, and they wouldn't have achieved their track records without a continuous effort in that front. Oil and gas is the exact same thing, because incidents in our sector are never easy ones to overcome.
Well, Your Excellency حقيقة يعني أثريتنا وبارك الله فيك وأحسن إليك. All I can say is I look forward to seeing you in person, inshallah, soon. Until then, on behalf of the Energy Institute, on behalf of all the delegates here today, and ourselves here at the Energy Institute, also Middle East, we really thank you very much for your time and for your insights. And here's also wishing you a very successful end of the year, inshallah. And as you said, we pray that things will get better with this COVID situation, and life will go back to normality. And thank you very much. We really benefited a lot from your insights, and hope to see you soon, inshallah.
Shukran, Dr. Wadah, a real pleasure. And thank you all for your patience.
الله يحفظك. الله يحفظك. يلا السلام عليكم. حياك الله. مع السلامة. So, ladies and gentlemen, that was His Excellency Sheikh Mohammed bin Khalifa Al Khalifa, who gave us some really good insights and connected the SDGs to what is happening in the energy space. We are running just a few minutes behind, so let me move on immediately to the next session. I just would like to introduce the moderator for the next session, who I'm going to be handing over to. So this next session is Mustafa Akbari Bijborala, who is a chartered energy engineer, principal engineer in technical services at Petrofac, and he's the manager for HSE. They're looking after programs, planning, and performance at ADNOC. So let me now hand over to you, Mustafa. Good morning, good afternoon. I take it you're in the UAE, so it's still good morning, sir. So over to you for this next session, and I think we will be should be finalizing this session, where you'll hand over back to me, inshallah, at 12:15 local time, which is 8:15 GMT. Thank you very much. Go ahead.
Thank you, Dr. Wadah. Thank you for the kind introduction. Actually, I'm currently out of UAE, but anyway, it's a wonderful morning over here as well. So to start the session, good day, everyone. I welcome you all to this technical session for reimagining. My name is Mustafa Wagjiparwala, and I shall be serving as moderator for the session. We have a very exciting session ahead with experts speaking on a wide range of topics relating to sustainability. We are still fresh from the recently concluded COP26 event at Glasgow. Many believe that we are far away from reaching our target of limiting temperature rise to within 1.5 degrees Celsius. Then there are the optimists who have seen the immense progress made during the event, as various commitments were announced by nations across the globe. In the end of the day, it will be the sustainability professionals and pioneers on the ground who would be delivering the necessary measures for achieving this outcome. We will be hearing from such industry leaders today in this session, who are showing us the way towards a more sustainable future. We will look at the gaps that may arise in our sustainability programs. We will also hear about how hybrid renewable energy could help oil and gas production be more sustainable. Also, we will gain some insight into the waste to fuel supply chain system. So before we start, here are some housekeeping rules for the session. Webinar is being recorded, so will be available for all registered participants for viewing later as well. All participants, except the speakers and me, of course, have been muted. All speakers will speak for 10 minutes, and at the end of the presentations, we will be having a Q&A session. Request all to take time to complete a short survey that will pop up in your browser at the end of this webinar. Your feedback will help us provide the highest value from future events such as this. So without any further delay, let me have the pleasure of introducing our first speaker, Amruta Shemkalyani. Amruta is the founder of AK Sustainability Advisory, Sustainability Tribe, and #ZeroWasteUAE social initiative. She is a sustainability advisor and a social entrepreneur. Her primary expertise is sustainability built environment as well as business sustainability. Amruta has helped many organizations embed sustainability into business over the last 14 years. At the same time, for more than 12 years, Amruta has inspired climate action in civil societies and business communities by building awareness. She is also an advisor to International Environment Organization and is a judge at various international sustainability awards. Amruta has been featured in numerous international media and recognized as UAE's top environmental thought leader. Amruta, I welcome you to today's session. The screen is yours.
Thank you very much. I hope everyone can hear me, and good morning to everyone. Actually, His Highness has covered so many points, so it's a bit challenging for me to cover further points, but here we go. So, okay. So, as we all know that by now, 2021, we have seen the global temperature rise reaching up to 1.2 degrees centigrade, even if it's written here 1.1 degrees centigrade. The correct one is 1.2 degrees centigrade from the pre-industrial era. And the global warming is so evident that even we can see how the summer is getting extended, and this year the winter is so delaying so much. So as we know, I would be just quickly going into this details that currently we are emitting 2,400 billion tons of CO2, and we have only 50% chances now left to reach keep our temperature, global temperature, below 1.5 degree centigrade as per IPCC report, which is again updated in November 21 after the COP. But we have definitely reached this point of no return. I'm not going to go into these details much because I think we are all very aware of that. So let's look at why actually businesses are looking into sustainability, and let's say even for energy sector. So there is this government enforcement or regulatory bodies putting some regulations. This is one of the reasons why many companies are going ahead with. One of the good examples of that is EU carbon border tax, which will be implemented in January 2026. And what this tax is going to do is it's part of EU's 2050 net zero emission. I'm just giving you this as an example, but there will be many. There will be many upcoming regulations or government enforcement regionally, locally, as well as internationally. So what EU carbon tax, border tax is going to do is companies will have to pay for the carbon emission associated with their products or materials. And the industries mostly affected because of this will be steel, cement, aluminum, chemicals, and energy. So this is one of the example. It is estimated that around 75 euro per metric ton of CO2 emission would be the tax, estimated tax. Then another one challenge is financial needs. So globally, the financial institutes are now looking into reducing carbon emission into their portfolio. So they are putting financial restrictions to give lending or funding to carbon emitting businesses. Looking at the energy sector, this is where the energy production, fossil fuel energy production is hitting hard. So if you look at the data on Institute for Energy Economics and Financial Analysis, IEEFA.org, you can actually see how different banks and financial institutes are putting their restrictions on lending. Right now, what their focus is, oil sands is restricted the most because it's very carbon intense operations. But definitely, because of these newer government enforcement, there will be more restrictions for the fossil fuel lending from the financial institutes. Then there is corporate social responsibility. Businesses around the world want to step up, go beyond what they have been doing so far, and they really want to embrace sustainability. Stakeholder demand is another one. It is in a way linked to the financial needs as well, but there is another one which is human resource. Now, it is getting more difficult for companies or businesses which are carbon intense to attract human resource and keep them for longer period of time, because newer generation or people are looking to move towards career. And I personally am seeing it a lot, where a lot of professionals are reaching out because they want to switch their career to more sustainable careers or more sustainable businesses. So this is going to be another tough challenge. Then marketing, communication, and competition in the market. Obviously, the competition in the market is going to be very, very cutthroat in a way, because more businesses are going to have promising sustainability goals or ambitious sustainability efforts. So to be able to survive in the market as a leader, companies need to move forward towards sustainability more and more. So what are the industry best practices right now in the energy industry? I'm talking about a bit of regional aspect here. Energy efficiency is where a lot of oil and gas or fossil fuel companies are looking into. They are working on technologies or innovations or updating their processes, making it more efficient so that it is energy efficient. Their processes, extraction, production, transportation, all of it. Then they are also looking into reducing the energy demand of their extraction, production, and processes. Definitely CSR projects are always there, and there is a tricky situation when it comes to CSR projects, because sometimes corporate social responsibility projects are not really bringing any reduction in greenhouse gases. They are very peripheral or on away from the actual GHG or decarbonization. So sometimes it also, there is a risk of getting it known as greenwashing, especially looking at the current customer or newer human resource, how savvy they are when it comes to sustainability. So this is another risk. But though even if a best practice, it's very tricky to actually make sure that without greenwashing following through CSR projects. So I would like to now go towards the next topic, that what are the biggest sustainability gaps we can see regionally, is the risks. Risks for the businesses internally, externally, short-term, as well as long-term. So when I'm saying lack of long-term vision, obviously it's not applicable for everyone, but this is a general market study, you could say. for the regional fossil fuel industry, where we need to look into the risk which are internal, external, not just short term, but also long term. So if we look at the financial risk of the sustainability gaps, is apart from the funding and lending, there is this another financial risk, which is market price risk, which actually His Excellency also touched upon. But as the renewable energy prices are dropping, it is actually creating a huge risk for fossil fuel industry. Actually, according to the Carbon Tracker Initiative, I found this data that third of fossil fuel investment planned through 2030 risk failing to deliver adequate returns for developers under the newer climate policies, which is very, very important to understand that how these financial risks are also there. Then the second risk, which is highly talked about, is stranded asset. A lot of the times, fossil fuel industries are seeing that their infrastructure.
Yes. We're just in the last 1 minute, so please, I will request you to speed up. And...
Sure. So, okay. So stranded asset is one of it. Human resource, I think I have already covered that. Fine and tax, definitely there will be more fines and tax as the climate policies are changing and developing around the world. So next, I would like to say, what can we do in terms of closing gaps? So if the industries regionally go to thorough ESG process where they are focusing on materiality, trying to track it down, the risk, internal, external, short-term, long-term, and accordingly actually implementing sustainability. If they are bringing innovation, then the impact-driven innovation where actual decarbonization is happening. They have a huge potential of using their own human resource and building capacity for sustainability through trainings and also, the fossil fuel industry or energy industry, I would say, has many capabilities which will be very nicely used to transition and move towards diversification, towards more decarbonization solutions. So could be moving towards renewable diversification, towards renewable energy. And there are companies like BP, Shell, or Norway's Statoil, which are already doing it around the world, investing into EV structure, car charging network, or the wind, floating wind farm, Statoil has done it. Definitely, one of the most important thing is partnership, collaboration, and mutual exchange and support between the companies as well as between the sectors. So could be traditional or non-renewable energy sector and renewable energy sector, and using existing capabilities, years of expertise, capabilities like supply chain relationship, B2B, access to B2B customers, all of that could be utilized towards actually bringing decarbonization and reducing greenhouse gases. So I think, yeah, we don't have enough time, but this is it. I would like to conclude with that. Yeah.
Thanks, Amruta, for the wonderful presentation. Now I would like to introduce our next speaker, Carlos Raviero. Carlos is a national of Trinidad and Tobago. He received his industrial qualifications in electrical and electronic engineering process plant operations from the John S. Donaldson Technical Institute. After working in the telecommunication services as an engineering planner, he continued his professional education in UK, graduating from University of Greenwich in London with a bachelor's degree in electrical and electronic engineering technology, and completing a PG and in sustainability energy systems from Queen Mary University. After working in the oil and gas services industries in Saudi Arabia for a number of years, he became an active in the energy management, oil and gas, renewable energy to optimize conventional energy generation and manage the new energy transition towards renewable energy and battery energy storage. This propelled him in the international arena, holding the position of Business Development Manager for Hybrid Renewable Energy Microgrid for Europe, the Middle East and Africa, with the Comp App Group based in Czech Republic. He also completed his energy management professional accreditation, graduating in 2018 from Robert Gordon University, Aberdeen, with an MSc degree in energy management, oil, gas, and renewables. He is currently consulting for the implementation of solar PV power plant for a number of international companies in Europe, including Agile Europe, Reintech Energy Solutions, Solar Edge, to name a few. Carlos, I welcome you to today's session. The screen is yours.
Okay, good morning, everyone. Thank you very much for having me here, Mustafa, and the rest of the Energy Institute team. I am based here in Prague, Czech Republic, and we operate under Reintech, which is basically energy management company, consultancy, and also system integrator. My focus will remain in terms of having and implementing sustainable energy systems, which is basically a collaboration between all of the different energy inputs along the entire value chain. We're focusing on the integration of hybrid microgrids, which basically answers that solution or brings that solution to the energy industry. How can we collaborate? How can we integrate all of these energy generation inputs to having a sustainable energy systems? Some of the speakers that touched on the economics, some speakers that touched on the environmental impacts. Many of the other speakers that touch on oil production, oil and gas, the carbon energy production. But what is key to look at, how can we make energy systems work for us? How can we realize the values, not only in terms of satisfying financial institutions, in terms of having their new investment, but also empowering existing energy producers to capitalize on new technologies. So we'll examine the role of renewables within the oil and gas industry. How can we find the correct mix to satisfy the demand? It's no longer a challenge, because when I started in this industry, let's say about 10 years ago, it had that big conflict, or what you call challenge. It was oil and gas against renewables. So, renewables and climate change activists and environmentalists against the oil and gas company. But now what we are seeing that transition moving towards, from not only oil and gas or petrochemicals or carbon intensive industries, but we are now embracing renewable energy. One particular renewable energy which have proved to be one of the most cost effective and efficient renewable energies, solar photovoltaic technology. So to have an idea, why go after such an integration? Why develop hybrid renewable energy microgrids for the oil and gas industry? From my experience working in the Middle East, I've noticed where there's drilling activities, or where there is well testing activity, or where there's pre-production activity, or even production activities, there's always diesel gensets. Diesel gensets, what I would consider to be the backbone of the oil and gas industry. They are at every site. They need to be refueled. You need to manage a refueling chain. You have to have service contracts, truck drivers. All of these things goes into maintaining power at whichever site. But one of the noticeable facts is the abundance of solar energy, which is, as you know, the Middle East it is one of what you consider the Sun Belt. It is one of the most productive place in terms, if you decide to deploy renewable energy in terms of photovoltaic. But there were challenges. There were challenges with that technology. Up to 5 years ago, they were experimenting with new thin film solar PV modules, which can tolerate higher temperatures, but those were very expensive, and their energy conversion were very low. 5 years ago, we were seeing solar PV modules producing 120, 230 watts per module. Now we have gone way past that. Silicon have fallen in price. Production have increased of solar PV modules, and now you're having solar PV modules 450 watts per module, or even some manufacturers they are going to 500 and 600 modules, 600 watts per module. So it's basically finding that solution for a cleaner on-site power generation, which is, in my field, it is simple as a system integrator. It is simple, but conveying that message to conventional on-site power producers, though the genset companies, there will be doubts. But what we have done it in the Middle East, we have done it across Europe, we have done it in Africa. We have demonstrated that you can actually dispatch a renewable energy power grid at any point in time. Basically, we are having these are 20-foot containers, and they are hybrid renewable microgrids. It is simple as dispatching your gensets. In all operations, one of the key aspects you'll meet is your diesel genset, and you need to match that with energy production from a renewable source, photovoltaic. Manufacturers of photovoltaic inverters, they are far advanced in terms of how they produce, what type of conditions they can operate, high humidity, high temperature. And we have photovoltaic modules, which is solar PV panels in some instances. They are more heat tolerant, and they maintain production. The other aspect of it, we're now integrating in terms of energy storage. So what you will see here, this is one of a typical site you would find in the Middle East. There are two approaches you can have for these, what I would consider small installation, low capacity, let's say about 100 kilowatt. At that site, it was typically, you will have a diesel genset sitting, placed there with a fuel tank. And those are the key components you wouldn't normally have in the oil field. In some oil fields, I've seen up to 300 of these at every particular well, which is basically, it's a small genset, a fuel tank, and it's operating there. And then you have a service contract, and you have those contractors, they go drive through that oil field on a daily basis, refueling those tanks, if it's a 24-hour operation or if it's a critical operation. But what we can do to mitigate against that sort of expense, and also in terms of the environmental impact, we can add solar PV and battery energy storage to that operation, which we have proved you can have as much as 60% reduction in fuel consumption, and that also translates into the reduction in carbon emissions. So renewables in the oil field is where the future is for oil field operation, and there's no other constraint in terms of dispatchable. No particular system has to be a permanent system. These hybrid power plants, they are mobile, they can be dispatched, and they can be reassembled or even transported to another location. So these are temporary power plants which serves their purpose as a temporary system, but to meet the energy demands. But not only in terms of these hybrid power plants, we are now seeing the role of energy storage within the entire system. Again, it's all about cost, finance. It's all about your return on your investment. Prior to the last 5 years, energy storage, it was one of the most expensive investment you could have made. I remember the first system we decided to integrate in the Middle East. That energy storage system was costing just over $4,000 US.
Carlos, just to remind, we have 1 minute left. Huh? Thank you so much.
Yeah, for 2.4. So the application and implementation of this is straightforward. It's energy generation from solar PV. It's also energy storage, which which again facilitates the non-sunlight hours, and it's the integration of diesel genset. So this will solve that issue of how we can have more or less a safe, reliable supply, safe security of supply, and reliability for dispatching renewable energy along with conventional thermal power plants. And I see it as a future. We have done it. It has been implemented, and it has proved very cost effective, and the return on investment is good. So to add value to the oil and gas industry, we'll be using less of your fuel you produce to try to produce more fuel when you look from a drilling and exploration point of view. So we return those barrels of oil into your revenue stream. Thank you very much.
Thanks, Carlos, for your amazing presentation. As our final speaker for this session, I would like to introduce Chris Sim. Chris is a managing consultant at E4Tech and jointly leads the firm's work on low carbon fuels and sustainable chemicals. Since joining E4Tech, he has been pivotal in delivering in a variety of projects, including advanced biofuel and power to liquids production technologies, as well as refinery co-processing of biomass, feedstock sourcing, and well-to-wheel greenhouse gas evaluations. He previously worked as a chemical engineer for Shell in the Netherlands and Singapore in their petrochemicals business, where he developed his expertise in the areas of concept development, techno-economic analysis, operations support, and competitor analysis studies. Chris, I welcome you to today's session. The screen is yours. Chris, could you please unmute?
Hi, yeah, sorry, I had to give back control to unmute myself. Can you give me back control now? Thanks. Great, sorry about that. And thank you very much, Mustafa, for the warm welcome. And I'm looking forward to giving this presentation, which is about waste to fuel supply chains. And thank you very much, Mustafa, for giving an introduction to myself. So I won't talk more about myself. I'll talk a little bit about who E4Tech are very quickly. I'm just trying to control the screen. Okay. So just very quickly, E4Tech, we're a sustainable energy strategy consultancy, and we use our deep expertise in technology, policy, and the business environment to help corporates, startups, and governments alike with strategic decisions. Oh, I just cut out for a second. Since June of this year, E4Tech joined the ERM. Can everyone hear me okay?
Yes, please, Chris, go ahead.
Sorry, it just keeps cutting out at the moment. It's a bit weird. Okay, sorry about that. So just a very quick introduction to the study. What was it about? So we were commissioned, so E4Tech, we were commissioned by the Energy Institute and Konkawa to undertake the study, which was a technical analysis, mainly based on literature of waste to fuel technology pathways that could be integrated into the European refining system. For those of you who are familiar with it, there was a similar study conducted by Konkawa, but on a different set of feedstocks. In this study, we considered wastes as the focus. And really, it was about understanding what are these different types of waste and what could be the most attractive Yeah, sorry, it just keeps cutting out. I'm not sure why. I need control back, sorry, of the screen. It keeps disconnecting me. Okay, good. But before we get into some of the findings of the study, let me just explain about the waste framework for best understanding how to use resources, really, and how they should be treated at the end of their life. So really, waste should be prevented first and foremost, of course. That's why it's at the top of the waste hierarchy. And then secondly, it should be reused and then recycled, then recovered, and then as a very last resort, disposed. So fuel sits, I'm not sure if you guys can still hear me. Mustafa, are you able to hear me? It just keeps saying
I'm able to hear you right now, but I think
every
you keep
5 seconds.
cutting off. Please continue.
Hello?
Hello, Chris? Please go ahead.
Hi, can I just check if people can hear me?
Chris, we can hear you.
Okay, I'll try to continue. So fuel sits within the recovery part of the hierarchy. So you can see it's relatively low down the waste hierarchy, which you might not think is a good thing. But the important thing to consider is, where do these wastes currently go? If these wastes are currently going lower down the waste hierarchy than fuels, then if you are to use these wastes to produce fuels, then of course that is a beneficial thing from the waste hierarchy perspective. So let's keep that in mind. I'll try to go a bit quicker. If somebody could flick the slides for me, because I think if you give me control, that seems to be causing the problem with the connection. So if you get to the next slide. Next one, please. So which feedstocks did we, so in this section of the presentation, I'm just going to give you a very quick overview of the pathways we picked and the feedstocks we considered. I'm not going to go into huge detail here, but initially we considered 7 feedstocks in the EU, and we had to choose 4 of these for detailed study. What you can see is we've listed the volumes available of these different wastes in the EU, so we can see large volumes of waste, large volume waste such as mixed residual waste, so that's your everyday black bin bag waste, down to smaller volumes such as used tires. And you can also see, as I was just explaining, we considered the current end-of-life fate of these wastes. So for example, mixed residual waste, most of it ends up in landfill or energy from waste, which generally is considered to be lower down the waste hierarchy than producing fuels. So what we had to do was to pick 4 of these and match them to so-called primary conversion technologies. Next slide, please. So these primary conversion technologies are the technologies that produce an intermediate synthetic crude, essentially, that can be processed by different refinery process units. So what this slide summarizes is which feedstocks we matched to which primary conversion technology. So I won't go into all the details just in view of time, but for example, for mixed plastic waste, it's currently used for purposes lower down the waste hierarchy in fields. It mainly ends up in energy from waste and landfill. And this was matched to pyrolysis because some companies are already developing plants mainly focusing on chemical recycling, but the similar technology could be used. So we looked at that. Another example, we picked municipal biowaste, so that's food and garden waste. This is available in large volumes in the EU and our existing supply chains for its collection. This was matched to anaerobic digestion because this is a technology that can handle the moisture in these feedstocks, but also it's a widely proven technology. Next slide, please. So what we did is what you can see on the left-hand two columns of the table are the waste primary conversion combinations that I just explained. And what we then did was examine, okay, if we take the primary product, so that's the middle column that's produced from these, and then we put them through the refineries, or through different refineries, what could be the different pathways? So generally we considered 3 pathways per feedstock primary conversion technology combination. You can see generally we thought of going via a crude distillation unit, fluidized catalytic cracker, and lastly for hydrocracking. The only exception to that was the hydrothermal liquefaction oil, which was not deemed suitable for processing directly in the crude distillation unit due to the acidity, and this was looked at via hydrotreating. Now, of course, in the actual study itself, there are many details about all these steps, in particular on the refinery upgrading step. But of course, we don't have time to go through this in detail. But this is just to highlight some of the content that's in that report. Next slide, please. So lastly,
Chris, I will just request you to please quickly summarize.
Yes, yeah, I'll just be 2 minutes, sure. Yeah, so in terms of overall study findings, so next slide, please. Just trying to summarize 5 key challenges of waste to fuel pathways. So firstly, there are key technical challenges across all these supply chains, but a lot of them lie in the refinery upgrading steps. In terms of scale, due to the low geographical density of these feedstocks, many of these primary conversion steps are much smaller than current refinery operation. In terms of policy and regulation, it's complex. Some policies support and others hinder the use of these wastes for fuels. Economics, often it's very difficult to estimate CapEx and OpEx due to specific local conditions, but also gate fees, which you can receive for these wastes, can be an important help to project developers. And lastly, in terms of the pathway technology readiness level, some steps are already proven actually, but the overall pathways are generally at lower TRLs. If you go to the next slide, please. And just very quickly to wrap up, and just some thoughts on what's the future of waste to fuels pathways in the energy transition. Well, from a waste hierarchy perspective, I've already explained that the use of these feedstocks for fuels may not be seen as being as favorable as using them for recycling. But for example, it's important to note that not all waste can be mechanically recycled, and then chemical recycling technologies also can't take such a big range of waste, and they are also not yet at a commercial scale. So that's important to consider. Secondly, in terms of the greenhouse gas saving potential, if you divert non-recyclable waste feedstocks away from energy from waste, away from landfill, you can actually get significant GHG savings. So showing the role of waste to fuels in delivering on net zero potentially. And lastly, in terms of refinery asset utilization, integrating these pathways into refineries can help refineries use lower carbon feedstocks. But as I've mentioned, the relatively small volume of these wastes in comparison to the scale of refineries mean that if you want to decarbonize the refineries on the scope 1, 2, and 3 basis, other complementary feedstocks may be needed for full decarbonization. So thank you for that. I hope you enjoyed the presentation. Apologies for the connection issues. It wasn't the internet on my side. I think it was Zoom. But of course, happy to take further questions in the Q&A, and feel free to get in touch with me directly if you'd like to learn more. Thank you very much.
Thanks, Chris, for the wonderful presentation. We shall now commence the Q&A session. I encourage all to post their questions in the Q&A or chat box, and we shall go through them as we go along. I request the speakers to kindly turn on their cameras. Chris, you are here. That is here as Carlos, can I request you to please turn on your camera?
Sorry about that. Okay, sorry. I am here.
Okay. So to get the proceedings going, a question over to Carlos first. Why do we need to use solar PV and battery storage instead of time-tested and trusted diesel generator sets for on-site power generation?
Okay, all right, thank you for that question. The particular aspect of that is we are looking at the environmental impact for these on-site power generations. As you know, thermal power generation is based on diesel fuel, and which have a high carbon emissions. But with the solar PV and battery energy storage, we now use a renewable source of power generation. And for those night hours or no sunlight hours, excess energy is stored in the battery energy storage. And that will be sufficient to deliver to these remote sites. Most of these remote sites, it's maximum 100 kilowatt hour, 100 kilowatts demand. So with battery energy storage and solar PV, we can meet those demands with no issue.
Okay, thank you so much. We have a question here from Jason for Chris. Can he expand on his statement about fuels from waste having a lower greenhouse gas potential than energy from waste when fuels are ultimately burned and release greenhouse gases? And the refining process also uses energy emitting greenhouse gases.
Yes, a very good question, Jason. So in order to answer this question, we must take a systems approach. So when we, in the LCA world, in the life cycle assessment world, we call it system expansion methodology. I'm not sure if you're familiar with that. So imagine if we have a system today where the base case is, if I want to make electricity, I am burning, say, municipal solid waste in energy from waste plant. That's one aspect to make electricity. And I'm using crude oil to make jet fuel, let's say. I then take the case of waste to fuel. So I'm diverting the municipal solid waste away. Excuse me, let me get a bit of water. I'm diverting the municipal solid waste away from the energy from waste plant and towards making sustainable aviation fuel, jet fuel. So that's the new case. But then I have to, of course, assuming I still need the electricity, replace the energy from waste electricity with something else. And let's say I can replace that with renewables, say, or nuclear, something very low carbon. So what you'll notice is if you compare the base case where you made electricity from municipal solid waste and jet fuel from fossil fuel, and the new case where I make electricity from wind and I make jet fuel from municipal solid waste, if you calculate the difference in the system GHGs of the two situations, you'll see a reduction in greenhouse gas emissions. There's also a similar analogy if you divert a municipal solid waste away from landfill and towards jet fuel production, because in uncapped landfill, if you put municipal solid waste there, because there's a lot of food waste is a big problem, because there's a lot of food waste in that municipal solid waste. When it degrades in the landfill, it releases a lot of methane. As you know, methane is a much more powerful greenhouse gas than CO2. So actually, for countries where there are lots of uncapped landfills, diverting municipal solid waste away from landfills generally is a good thing from a greenhouse gas perspective. So hopefully that answers your question, Jason.
Thank you, Chris. A question from my side to Amruta. We have seen many oil and gas companies taking a lot of initiatives to make their operations more energy efficient, for example. They take a lot of sustainability initiatives as well with regards to protecting the environment and the surroundings area for their plants and things like that. But they are always criticized that this is just greenwashing. How do you think they can approach this better, to have a better image in the general community?
I think in terms of, because this kind of initiatives, the CSR initiatives help them in marketing and, communicating their sustainability efforts. So if these smaller projects are, there is a risk of greenwashing, then I personally believe that they should communicate their more significant sustainability efforts through their marketing and communication. So for example, if they are actually doing something to reduce the energy, or even if they are doing bigger things like diversification or anything, I think the communication of sustainability has to be more inclusive of all the aspects, because a lot of the time communications team feel that it is way too technical, should we communicate that? But I think our human resource, or the customers or people, society in general is more aware now, and they want to understand more. So whatever their actual sustainability efforts are in terms of reduction of greenhouse gases, or in terms of more significant impact, they should definitely communicate that. Yeah.
Okay, thank you so much. Let us take one last question, because we are slightly constrained on time. We lost a lot of time in our presentation. So one last question over to Carlos. Do you see renewables as a major challenge to the conventional power generations for remote sites?
Good question, but a short answer, no. Why is it possible? Because what we are looking at is remote sites. We are looking at higher power concentrations, and renewables is something that you'll go hand in hand with the oil and gas industry. As we know, we have seen across all of the oil and gas companies, they are heavily invested in renewables. Total, the French company, they have heavily invested in renewables. We have Shell, BP, the likes like those. But there are many more, even smaller producers, they are more or less invested. And even within the Middle East, we have seen both Bapco and Saudi Aramco heavily invested into renewables. So under our classification, we see energy production. Yes, there are two types of that. There are liquid carbons that result in carbon emissions, but there are also energy productions from renewables. So once you are involved in that industry, it's an easy conversion or integration for energy production. And soon, as we are now seeing, the production of green carbons. And I like that term, what is being thrown around, that greenwashing. I like greenwashing because I'm seeing it as one of that solution that will actually empower these conventional energy producers to finally embrace and get on board and say, okay, here's what renewables, it's here to stay. And we need to continue being an energy producer. But again, we have to have a lot of carbon reduction within that energy value chain. And we have to reduce the effects of it in terms of the greenhouse gases, as highlighted by Chris. So it's no longer one or the other, but it's finding the right mix. So yes, renewables, they have a major role to play in the future of energy systems.
Okay, thank you. I think we can squeeze in one final question. This question has come in from Ahmed Salman. He's thanking you for your presentation and valuable information. And his question is, as far as legislation concerned, is the updates on the legal requirements play the main role to develop the waste to fuel concept?
Thanks, Ahmed. I was actually typing the answer just now, but maybe easier to answer. Thank you. It's quite a complicated question. I would generally say that, so the types of waste that I showed are either biogenic or recycled carbon. That's the terminology that's used in Europe and the UK. Generally speaking, for the waste which are either pure biogenic or for the biogenic component of them, so for example, the mixed residual waste, as I mentioned, has food waste, so that's the biogenic component, those already receive strong policy support, so revenue support, in both the UK and the EU in terms of producing fuels. Now, for the recycled carbon component, so for example, again, in mixed residual waste, you've got plastics and other kinds of originally fossil components. So plastic obviously originated from crude oil. That recycled carbon component, I would say that in the UK, that is currently has undergone consultation, and the final decision is being awaited from the UK government. And in the EU, a delegated act will hopefully be released in the next few months, clarifying the EU's position on the use of recycled carbon fuels. So unfortunately, there's not 100% clarity right now. I do think there are positive messages going towards recycled carbon fuels, but I don't want to, mislead you. We have to wait and see. But for the biogenic wastes, there is support. But of course, this is a very complex field, so do feel free to reach out to me. I believe, Mustafa, they have our email addresses. Correct me if I'm wrong. So feel free to drop a quick question and I'll see what I can do. But good question. Thank you.
Sure, thanks. Okay, I think we have reached the end of our session. Just to quickly summarize what we went through today's session, if I can quickly go through my scribbled notes here. We started off with a wonderful presentation with Ms. Amruta. She showed us the importance of sustainability, and how industry best practices are helping us become more sustainable. She highlighted, the challenges behind greenwashing and how we need to overcome this to be more sustainable in our operations. She also showed us that there are some gaps which we need to overcome in the long term as well as the short term to make sure we are able to reach our sustainability targets. And she also discussed some of the measures which we need to do to close some of the gaps, and how participation and collaboration from within the organization is important to achieve these targets. Next, it was a very insightful presentation by Carlos. He showed us, a kind of very interesting collaboration between oil and gas, the conventional sources of energy, as well as the renewable sources of energy, and to look beyond both industries looking at themselves as a conflict and rather as a collaboration. Of course, he talked about challenges. Every new thing has challenges, and of course, even these initiatives do come up with challenges, and how solar PV itself is of a great benefit, especially in the Middle East region. And he also showed us some good examples of how they were able to overcome some of these challenges in some live examples they have implemented in this industry. So thank you so much for your wonderful presentation. Finally, the presentation from Chris, it was a very insightful and a thoughtful presentation on how waste energy can be integrated with refinery operations. We understood the various type of waste and how they could be converted and how they can be associated with different technologies to integrate with refinery operations, and the different pathways that are available for achieving the final end product, converting the waste to fuel, for example. And he also discussed some very interesting challenges that we are facing when we are trying to implement these kind of solutions in a refinery. In terms of the capacities and the feedstock, the calorific value, for example, the concentration of the fuel itself, availability of the fuel. So these are all challenges. I hope, of course, we will be able to hopefully overcome these challenges in our future studies, and we're able to come up with a viable solution for the industry. Finally, I sincerely thank all the speakers for joining us today and enlightening us with their knowledge and expertise in the field of sustainability. Also, I would like to thank all the participants for attending today's session. It was a pleasure to have you all on board. Also, thanks to Energy Institute for giving me this opportunity to chair this wonderful session and be part of the Middle East HSE and Sustainability Conference. Thank you all.
Okay, ladies and gentlemen, thank you very much for joining us so far this morning. I'd like to also thank Mr. Mustafa Carlos, Chris, and Ruth for their participation also with us this morning. What we'll do now, it's 12:25. We were supposed to close at about 12:15, and take about 20 minutes. If I can ask that we come back, we'll start just slightly later at 12:45 GST time, which is about 8:45 GMT. So Bahrain is 1 hour behind, so that will be 11:45 Bahrain time. So if we can come back again in about 20 minutes, and then we'll start the last panel of the morning, where we'll have some exciting speakers as well, talking about the new energy future and what's possible for HSE and sustainability. Okay, so anyway, I'll see you guys back here in just less than 20 minutes. Okay, take care and have a good break. Thanks everyone so far this morning. Okay, good afternoon, ladies and gentlemen. We are back again. I think just to check with the event hosts, can everyone hear me?
Yeah, we can hear you.
Yeah. Okay. Thank you. Okay. Well, good afternoon, everyone. Assalamu alaikum. And so I'll be your moderator for this session that should take us to around about half past the 1 this afternoon local time GST, which is about 9:30, which will be about 9:30 GMT. We have on this panel 4 speakers, Mr. Mohammed Ghassan Farija, who is the environmental specialist in BAPCO. We have also Dr. Samia Youssef, who's chairperson at the Department of Natural Resources and Environment, and she's also the assistant professor for environmental engineering in the Arabian Gulf University. We have also Mr. Amjad Abdullah, who's the head of partnerships at IRENA, and also we have Dr. Zhendong Jing, who's the visiting professor from Imperial College London. I believe Dr. Jing will be making a short presentation, but what I'd like to do to start with is the topic of today's session is the new energy future, what possible for HSE and sustainability. So what I'd like to do is the following format with the names that are posted in ahead of me. What I'll do is I'll give each speaker about 5 minutes to give their opening speech, say about 5 or 7 minutes, and then because this is really a panel session, then we'll start taking questions from the floor. Okay, so thank you very much once again for joining us. And so is Mohammed Ghassan, are you there? Can you hear me?
Yes, I'm here. Yes.
Oh, okay, Mr. Mohammed. Assalamu alaikum, marhaba.
Yeah.
So what we'll do is what I'll ask is that if you can just give 5 minutes on your views on the subject area of the new energy future. Doesn't need to be 5 minutes, could be less if you wish. And just keep your camera on, and then I'll introduce the next speakers, who will also be given sort of 5 minutes to give the introduction. So go ahead, sir.
Okay. First of all, my name is Mohammed Ghassan. I am an environmental specialist working on the BOPCO modernization program. The BMP is a large-scale refinery expansion of the BOPCO refinery. Basically, we will be doubling our capacity while at the same time minimizing our environmental footprint. What I really wanted to focus on is the role of oil and gas within the future of the energy transformation. Now, we saw from the latest COP26 that occurred in Glasgow that there is a direction to go towards carbon neutral midway through the century. Some countries have stated that they wish to go carbon neutral by 2050. A few of the GCC have stated that 2060 is their current goal. commitments made as part of COP26 add up to will result in approximately 1.8 degrees Celsius in comparison to pre-industrial levels. That means we're still a little bit off the mark in terms of hitting that 1.6 target by the end of the century rather than exceeding it. For every 0.1 degree of warming, the impacts magnify, and these impacts will affect everyone's lives. There is no exception to this rule. What is really needed for the oil and gas is industry in order to continue is to reevaluate business as usual. We're talking about reevaluating finances in terms of companies and financial institutions have shown reticence to invest within fossil fuels within the future. So the question is, how do we look at oil and gas as something separate from just fossil fuels? What are the chemical components that can be made from them? Moreover, investment into carbon capture. This is something that has potential to allow the oil and gas industry to operate for years in the future if the industry can figure out a way to offset its own carbon emissions. At the same time, oil and gas needs to be heavily cautious in terms of its own offset strategies. In the past, we've seen companies who I will not name utilize certain strategies with questionable efficacy, often going into indigenous protected areas and basically extracting resources from them, while at the same time utilizing this to state that this was a carbon offset mitigation, when in fact studies have found that a lot of these activities end up becoming carbon net emitters. So I think an evaluation of potential carbon offsets is necessary for the future. Not only that, the oil and gas industry has been taking a holistic look at the future of the energy matrix. We're seeing a rise in the use of renewables, but a rise in the use of renewables will also necessitate great changes within the infrastructure of our energy grids, the utilization of batteries, for example, and we simply don't have the capacity to meet those needs at the current moment. So further investment is needed. There will also be a greater emphasis on efficiency in terms of totality of the energy industry, whether we're looking from the process side in terms of maximizing the efficiency of our process units, all the way to the user side in terms of manufacture, in terms of use of products which are more efficient, for example, energy efficient light bulbs, energy efficient heating. At the same time, decreasing our use of energy per capita. So while this has to be something that is looked at, this is a multifaceted area which we need to consider a vast number of critical aspects for. And no one company, no one organization can do this by themselves. It needs to be a public-private partnership between the general public, governmental regulators, financiers, and the companies themselves. If we look at the role that oil and gas plays within implementing the Sustainable Development Goals, we can see that they have a hand in virtually every single one. If we look at the issue of no poverty or zero hunger, health and well-being, we can see that oil and gas companies usually play a big role within the localities in which they're occupied, and thus really do contribute towards implementation of these things. For example, we have the area of gender inequality. The area of gender inequality has been something that, to be honest, the industry has been lagging in for some decades. However, we are seeing a slow but steady change within this field. And we're seeing more women in industry, and that's something to be commended. We're looking at greater innovation within the industry. We're looking at greater infrastructural challenges in the future. So with that, the message I want to get across with is, yes, this is a challenging transitional phase, but at the same time, it is one that it's very hard to determine what the future of this industry will look like. However, what we can say is this is probably the most exciting period to ever work within this industry, given the challenges ahead. So I wish you all good luck, and thank you. That's it.
Okay, thank you very much, Mohammed, for that introduction. You covered quite a few areas. I'll try to bring some of those back in the discussion inshallah. Can I ask Dr. or Professor Sumaya to go next, please?
Yes, hello everyone. Thank you, Dr. Wadah. I'm wondering, shall I share my presentation now, or is it just an introduction?
Yes, please.
I'm sorry.
Yes, please. But if you can keep the presentation to 5 to 7 minutes or so, if you can,
Sure.
please.
Okay. Yeah. So can you see my screen?
Yes, can.
First of all, I'd like to thank the Energy Institute for organizing this wonderful event or conference, and to hosting us today to talk about the importance of sustainability and sustainability practices. Today's speech is about sustainable solid waste management as a very important topic currently, especially with the challenges appeared recently and the global trend in mitigation of the climate change impacts. So as we know that the rapid urban development and population growth led to increase in waste generation rate, and actually the waste management is one of the major challenges in urban cities nowadays around the world. And so understanding the environmental pollution, waste management is essential to all. And actually, sustainable waste management should be based on technically sound approaches on eliminating or minimizing the health hazards while maintaining environmental quality, cost affordability, and public satisfaction. As we know, the increase in economic and developmental activities leads to an increase in waste generation, which leads to serious threats to the sustainability all over the world. So implementation of sustainable waste management strategy is important in any country to mitigate to harmful impacts, as we said, and for transforming into a circular economy by investing in green technologies that conserve the resources benefits, which has benefits on environment and economy and society. So waste is any unwanted or unusable materials and any substance which is discarded after primary use or it is worthless. So it is considered as a lost resource and not waste. So I prefer the term a lost resource rather than the waste, and it can be in solid or liquid or sludge phase. So the waste management activities are all the actions required to manage the waste from generation to its final disposal, which includes the collection, transportation, treatment, disposal of waste together with monitoring and regulation. Here, maybe this figure can show all the classification of waste. So it is classified into non-hazardous and hazardous based on its type, and it includes in the non-hazardous industrial, municipal waste, and hazardous. It can be again industrial, radioactive, and medical waste. And electronic waste as well. So non-hazardous mostly composed of the municipal waste, which is largely includes the domestic waste and construction demolition waste, commercial and agricultural. Domestic waste any waste can be organic and inorganic, and organic includes all the shown here classifications: food, paper, cardboard, animal waste, plastic, textile, rubber, oil, and grease, and wood. While the inorganic are the glass and metals. So what are the trends in solid waste management? The world generates 2 billion tons of solid waste annually, according to the World Bank, and it is expected to grow to 3.4 billion tons by 2050. So there is a positive correlation between waste generation and income level. As it's shown here, we can compare between all the areas in the world. So the Middle East and North Africa has the least tons per year generated compared to East Asia and Pacific, which has the highest rate and expected rates in 2050. Okay. So even waste composition differs across the income level countries, reflecting varied patterns of consumption. So accordingly, the high income countries generates less food and green waste, which is less than 30%, and more dry waste that could be recycled, including plastic, paper, cardboard, metal, and glass. And middle and low income countries generate mostly food and green waste, greater than 57%, while in low income countries, materials that could be recycled account only 20% of waste stream. Actually, in Bahrain, we have maybe the organic portion reached 70%. Okay, global waste composition percentages. Here we can see even the global classification for among all the income levels. So we can observe that the food and green portion is the highest, which reached 44%, while others, paper and cardboard, comes in the second place. Sustainable development and waste management, as we know that the development that meets the needs for the next generation and so that present without compromising the needs of the future generations, that meets their own needs while considering environmental, social, and economic aspects, called the sustainable development. So as we know, all that the sustainable development goals are 17 goals that are issued at 2015 and Paris Agreement, cannot be met unless waste management is addressed as a priority. Actually, the UNEP considered the waste management or SDG number 12, which is responsible for sustainable consumption and production, which has all the indicators related to the waste management, as the core goal for sustainable development goals. As we can see here, the responsible consumption and production is the core goal for all other goals. So while achieving goal number 12 through a sustainable waste management and reducing generation of waste, we can achieve all the other goals. For example, while reducing the food waste, for example, you are securing the food, you are providing food security, so you will realize or contribute in realizing the zero hunger and no poverty as well. Here we can see the CO2 concentration, parts per million.
Dr. Sumaya, if you can just take 2 more minutes, please, huh?
Sorry. We can observe the highest sector that is contribute in greenhouse gas emissions. The energy sector has the highest. And the hierarchy of waste management is the sustainability or integrated waste management way. We can see that the priority is always for avoidance and minimization of waste. Then it comes reusing and recycling of waste, then waste to energy. I have studied 6 different technologies to be adopted in Bahraini community. I have studied the feasibility of mainly combustion, gasification, pyrolysis, and anaerobic digestion, and RDF and composting, socially, economically, and environmentally. And we have discovered that the direct incineration is very feasible for Bahraini community based on the 3 criteria, and even the anaerobic digestion by enabling it by segregation at source and with other supportive policies. So it is highly recommended to transform to the model of the circular economy rather than the linear model. So take, make, use, and dispose the linear model. So we recommend the take, make, use, and recycle. And the most challenges or barriers against adoption of the green technologies related to the sustainable waste management in Bahrain was mainly related to social, political, economic, technical, managerial, environmental barriers or challenges. And we need incentives to investment in green technologies, innovative business models, national capacity building, markets for the end products. We need centralization of the waste management responsibility and coordination between all the stakeholders, beside the privatization of waste management sector and source segregation. Actually, food waste is Bahrain classified recently as the highest generator for food waste among Arab countries. So it reflects the non-sustainable consumption pattern among Bahraini community, and it is very prioritized to focus on food waste to prevent it. And Bahrain municipal solid waste, it's shown here, it doubles actually. We are generating 2 million tons per year. So most of our waste is food waste. Unfortunately, 230,000 tons per year is food among Bahraini waste, domestic waste. So 41% of domestic waste is food. So I have applied a feasibility study for using the anaerobic digestion for biofuel generation for Bahrain, and I found that we can generate 213.3 gigawatt hour, which equals 2% of current total power generation in Bahrain by using the anaerobic digestion for biodegradable waste portion of Bahraini waste, which equals, we can have revenues 1.62 million electricity annual revenues and save 4.5 million from waste dumping budget. And by using the incineration of 500,000 combustible waste, I have measured the calorific value of our waste, which was very high, 18.5 megajoule per kilogram. So we can produce accordingly 3,700 gigawatt hour per year, which can meet 20% of the total annual power generation in Bahrain and meet the target of Sustainable Energy Authority for waste to energy in the country. So here we have some priorities for food waste management as a priority for Bahraini waste management. Maybe we have no time to read them all, and small changes in our behavior matter. So keep your reusable shopping bag with you in the car, use small dishes rather than large, reduce your meals portion and eat healthy, donate food, for example, reuse food and innovate in cooking, sorting properly, compost at home. Remember, we eat to live and not live to eat. This is just to reduce the food portion. And we are not, after informing people that anaerobic digestion is feasible, we are not encouraging people to produce more waste, to have enough or sufficient feedstock to operate our facility. We just push them or encourage them towards the prevention and reduction from source through the sustainable lifestyle or consumption habits. So we need the capacity building. Actually, we are currently running the
Dr.
professional
Sumaya, if I can,
management.
Dr. Sumaya, sorry to interrupt you. If you can just please wrap up. Shukran.
Sure. Sorry, and here we have the global waste market. It is a very promising market. The global waste management market was valued 383.8 billion in 2020. And the industrial waste global market is also accounts for around 50% share for the overall waste generated globally. And we can see the trend here in that the market was 1.2 billion in 2018. It will be 2.5 billion by 2025. So always we remember the 9 R's: rethink, refuse, reduce, reuse, regift, repair, rent, recycle, and rot. And thank you.
Okay, thank you. Sorry to have rushed you, Dr. Sumaya. Yeah, no, but that was good. This is interesting. Anyway, I'll make some comments, inshallah, later. I just want to get through the rest of the panelists. I believe that the next panelist will be Mr. Amjad Abdullah. Mr. Amjad Abdullah, can I ask you to give your thoughts over 5 minutes, please? Thank you.
Yeah, my camera is not, I won't be able to switch on the camera, so it's only the, okay. Sorry, but I mean, is it only on the overall overview?
Your cameras come on. You're okay.
Yeah, it's just now, yeah, because, yeah.
Okay.
So
okay,
what's the question again? Can you repeat it? Because, yeah.
No, it's really not a question. It's your thoughts on the new energy future. What's possible for HSE and sustainability?
Right, right. No, thank you very much. First of all, let me also thank the organizers for the insightful event. Obviously, the energy future, which is very critical. I'm sure, I mean, you are all aware that the energy sector is undergoing a dynamic transition. The imperative of climate change, energy poverty, and energy security to underpin the development and industrial strategy have made the widespread adoption of renewable energy and related technologies is an integral part of the solution. Obviously, I'm sure, I mean, you are all aware what concluded at the Conference of the Parties to UNFCCC, and also the underlying science that there is no time for the pathway to net zero. Obviously, aligning with the 1.5-degree world to limit the temperature goal for the Paris Agreement, we obviously need to reduce 36.9 gigatons of CO2 by 2050. Just to name one of our IRENA's flagship publication, the World Energy Transition Outlook, the analysis shows that over 90% of the solutions to shape a 1.5-degree pathway definitely involves renewable energy through direct supply, electrification, energy efficiency, green hydrogen, bioenergy. I'm sure people have already talked about. Combined with carbon capture and storage, we do believe that all these are part of the package of the solutions. The technological avenues leading to a decarbonized energy systems have crystallized, dominated by solutions that can be deployed rapidly and at scale. Technologies, markets, and business models are continuously evolving, but there is no need to wait for new solutions. I'm sure there is ample solutions that we can start expediting it. Considerable advancement can be achieved with existing options, but taking the energy transition technologies to the necessary levels and the speed compatible with a 1.5-degree goal requires targeted policies and measures. Again, you were all aware what was the end result at the climate COP, that the reaffirming the need to achieve climate neutrality and limit the global mean temperature to increase 1.5 degrees. Obviously, IRENA's 1.5-degree pathway can achieve Glasgow Climate Pact ambition. Again, some of the analysis of World Energy Transition Outlook. I recognize and clearly understand the desire and need, and also some statistics. Let me be very brief. I know that we have limited time. According to our analysis, the flexibility would create at least 25,000 jobs. Each million invested in energy efficiency and create about 10 jobs. This could add 5.5 million more jobs by 2023. Further recovery investments linked to energy transition would boost GDP by an additional 1% in the next 3 years. With, of course, vast renewable energy potential, accelerating the energy transition can be immensely beneficial to the MENA region, and the transition is already underway. And we were very pleased to hear UAE and other countries coming up with their net zero targets. Renewables seen dramatic and cost reduction in the past decade. New solar and wind projects are undercutting the cheapest and least sustainable existing coal-fired plants. Obviously, as the Apex Intergovernmental Agency on Energy Transition, we believe that IRENA has responsibility and has been at the forefront of its support to member countries. I'll be happy to contribute on the IRENA's engagement. Do you want me to continue on the IRENA's engagement, or I can wait to the latter part? Sorry, your microphone is off. Your microphone is
Yes,
off.
Yes, Mr. Amjad. Yes. No, I mean, you can take another minute just to brief us on IRENA's engagement, and then we'll go to the last
Right.
panelist.
As I said, I mean, we are the Apex Intergovernmental Agency on Energy Transition, and we've kept climate action at the forefront and partnerships and international cooperation to support the member countries, obviously leveraging the membership. Our focus is shifting from enhanced ambition in NDC updates to NDC implementation, and our very much focus is on the NDC implementation and supporting the development of long-term development strategies to achieve the net zero carbon emission with our member countries. While most of the parties to the Paris Agreement continues to enhance their NDCs and raise their climate ambition, very few have set long-term low greenhouse gas emissions, but as the Apex agency, we are very happy and keen to engage with the member countries in supporting the initial set of countries who are forthcoming. And we are happy to inform that we are engaging a number of countries across the globe, mostly from the developing world. IRENA has been using vast body of knowledge and experience to provide substantive input to NDC enhancement and implementation process. We are confident in IRENA defined potential areas that we have the strength, and the request received directly from the member countries, we are helping to implement those policies and measures. Obviously, we are engaging on the request of the member countries, and IRENA's engagement on the resilience and adaptation is something that is clearly one of the outcomes that foresees in the upcoming COP27 and COP28, respectively, in Egypt and in UAE, and we are very much looking forward to engage here with the member countries. Again, green hydrogen has emerged as a key pillar to support countries to achieve their net zero. More specific on the MENA region, green hydrogen has emerged as a priority across all countries, with national hydrogen strategies already underway, and national committees have already been established on the ground. It was evident that the countries in North Africa and the GCC have the comparative advantage in developing ambitious renewable energy strategies to cater for growing energy demand, recognizing potential in terms of land and resources to produce green hydrogen, not only to meet domestic consumptions and decarbonize end-use sectors, but also for export in Europe and other parts of the world. Furthermore, countries will leverage on the wealth of knowledge from the LNG experience. IRENA has organized a number of workshops.
Okay, Mr. Amjad. Yeah, Mr. Amjad, if we can wrap up here, please.
I'll be brief in another minute or two. Just to provide some of the perspectives that the recent engagements where IRENA has engaged. We've engaged with European Union, International Hub Berlin, GIZ, as well as jointly towards, we've organized a number of events and workshops. One of the reasons, in jointly towards a renewable-based future, a dialogue between EU and North Africa states on a regulatory framework to develop green hydrogen supply, demand, and trade. This workshop was part of the series of workshops which we have organized through the European Union funded Strategic Partnership for Implementation of the Paris Agreement. We've also helped the countries, and all countries have recognized that there are certain challenges that need to be addressed to support the wide-scale deployment of green hydrogen, including the following. Capacity building is essential to support the development of green hydrogen, support in research and development to build technology and industry. Success of green hydrogen hinges on private sector. Therefore, there is a need to develop regulatory framework for a conducive environment to encourage private sector investments to support production, infrastructure, and road networks. Appropriate certification schemes that needs to be established and a common methodology that needs to put in place to support global hydrogen market. I'll be happy to come back again.
Okay, thank you very much, Amjad. Okay, I'm just cautious of time. We're already 20 minutes past now, nearly. So I'd like to get Dr. Jing next to please give us his insights into the carbon capture, utilization, and storage. Dr. Jing, if I can ask you to stick to 10 minutes, that would be really appreciated. Thank you.
Thanks. Thank you very much. Can you hear me okay, Dr. Wada?
Yes, we can hear you very well. Thank you.
Yes, thank you for the introduction. Yes, indeed, I will try to keep to the time available. I will focus on carbon capture, utilization, and storage in my introduction here as part of this New Energy Future session. As mentioned here, I'm a visiting professor at Imperial College London. I'm also currently the technology manager for Shell in Oman. Just a brief introduction of the process for people who may not be familiar with it. So this is a diagram showing the CCUS workflow. So on the left here, you see the capture part and compression. Typically comes from CO2 comes from a power plant. It could also be from a blue hydrogen project or any other blue chemical project where with CO2 as a byproduct. Then you have to build a pipeline or shipping to transport the CO2 from the source to where you want to utilize or to store. On the right-hand side is the subsurface storage, where you inject CO2 into a subsurface geological formation. Typically, this could be mature or depleted oil and gas reservoirs. It could also be a aquifer, where you have the right pore space, the right seal, and enough capacity for storage. The utilization part could either be surface or subsurface. So surface, you'd be chemical processes utilizing CO2, nature-based processes, carbonization, or subsurface utilization, that is injecting into oil reservoirs for enhanced oil recovery, but also with storage as a dual objective. So just a quick intro. And this slide shows the current ongoing projects that Shell is involved in CCUS. You also hear people use the word CCS, that is the focus on capture, carbon capture and storage rather than utilization. So here we have on the left, across the globe, projects in different status of maturity. The project which are highlighting in red color is either operational or post-FID, post-final investment decision project. And these blue projects are the earlier stage, pre-FID project. You can see that it ranges from Norway, the Lausanite project, which I'm going to come to as example. In Canada, we have the Quest project, CCS, has been in operation for quite a few years. And then you have other projects across. Some are operated by our partners and some are operated by ourselves. On the right-hand side, just to highlight why are we doing it. So CCS is important enabler. Whichever net zero pathway you choose to go, CCS is part of the solution. You really need to do CCS in order to achieve what you want to achieve in the net zero future. So here we look at multiples. We wanted to get to net zero emission from our own operations, upstream or downstream. We'd like to look at a low carbon gas future, that is to have a product that is less carbon intense, could be liquefied natural gas or other product. There's a lot of energy and discussion in terms of the future of hydrogen and CO2, in particular looking at blue hydrogen solutions where CO2 need to be stored. And that CCS plays an important role to enable hydrogen, low carbon hydrogen. There are other initiatives, for example, bioenergy using CCS, decarbonizing sectors. And here the example is the transportation sector to decarbonize. And then the final one is there's also research and development ongoing for direct air capture of CO2 And once you capture CO2, what are you going to do with it? So the storage, CCS, CCUS, plays an important role in this future energy space. Just quickly, 2 examples before I wrap up. So you probably have heard our Quest CCS project in Canada. I myself had the pleasure, and my team in Houston had the pleasure to be part of the subsurface studies in the early stage. So this is a fully integrated commercial scale CCS project that captures CO2 from our Scotford upgrader plant and then transport by a pipeline for 65 kilometers to a storage site that is a deep saline aquifer. It's not a depleted oil gas reservoir, but it is a saline aquifer at the depth of 2 kilometers below surface. So project is designed for 25 years and with injection capacity of 1 million tons CO2 per year. The project has been on stream since 2016, and we have already stored over 4 million tons of CO2. So this is a project that is ongoing successfully, and there is potential to upscale, to increase the storage capacity with future phases of this project. Another project which is relatively new, it's called Northern Light project. We are partnering with Equinor and with Total. And this is in Norway, where we capture CO2 from a power plant. And instead of using a pipeline, we're actually using shipping. CO2 in dense liquid phase is transported by ship to a onshore injection site in the middle of the plot, where then we inject via a pipeline to a offshore site, which is the we call it, it's quite next to the Troll field, and that is about 2 to 3 kilometers the reservoir depth, and that has substantial storage capacity of estimated 100 million ton in total. Yeah. So the project involves CO2 capture, storage, or shipping by using tankers, and then a receiving terminal onshore, and then the injection offshore subsea. And that has a capacity of 5 million ton CO2 per year. Yeah. So these are 2 projects which I use it as an example. But in closing, what I really would like to say is that we have great opportunity in the Middle East. Here I'm in Oman, of course. We have a rich portfolio of oil and gas fields in different stages of development. In neighboring countries in the region, there are great opportunities to do CCUS, combining CO2 storage with enhanced oil recovery. Of course, we need to work on enablers, including regulatory framework, and measurement, monitoring, and verification requirements, as well as funding model for future CO2 project. But we are very well positioned in terms of skills of the oil and gas energy professionals we have in the industry, as well as the knowledge we have about reservoirs in terms of static, geological, as well as dynamic in terms of geomechanics, production characteristics. So we are in a much better position to scale up CCUS in this region than other parts. We're competitive, we can lower down the cost. And with the option of shipping CO2, there is the opportunity to use it as a store, not only for domestic CO2 sources, but potentially also for foreign and other CO2 sources. With that, Dr. Wada, I would like to hand over back to you, and happy to participate in the Q&A session later.
Okay, Dr. Jing, thank you very, very much for a very exciting presentation. I'd like to also thank all of the speakers this morning. Let me just try to give a one minute summary of the thoughts that were shared by our 4 panelists, and then if you can please, if you have any questions from the floor, please put them into the chat and send them across, and I'll take your questions as well. And I will have maybe a few of my own. So Mohammed started with talking about the issue and the challenge of climate change. He gave a bit of a holistic introduction and the global warming issues. and explained how even changes, small changes like 0.1 of a degree can have an impact. And and he also spoke about how the look at oil and gas currently, of course, resonated with some of the stuff that His Excellency the Minister was saying this morning with regards to the lack of investment in oil and gas, and how that is causing also a bit of a problem, given that oil and gas still remains the only transition to keep the energy prices at a reasonable amount and invest in it. But he said that also the investment into renewables is happening, and he spoke about the impacts of exploration. He said that we should look at that holistically to also understand the kind of impacts, and it's not only about the carbon management, but it's looking at things sort of holistically as well, to look at the environmental benefits. And he spoke about carbon offsets, and he also spoke about the approaches, that the multi-pronged approaches which are required in terms of looking at capacity, in terms of improving batteries, improving efficiency in the process units, and various different areas of lighting, etc., and reduce demand, also the use per capita, try to manage the use per capita. And spoke about the oil and gas play a large role in also CSR, and that we should not forget that, and gender equality, and how it has also helped drive innovation and gender and greater investment into this area. Then we had Dr. Sumaya, who gave us a very in-depth presentation actually on waste management. She spoke about the challenges, and she spoke about the natural growth with urbanization. She spoke about the waste management, the handling, and she gave us some good statistics into what's happening, and she also spoke about the managing waste through these technologies, and spoke about the consideration to circular model rather than the linear model. And it was interesting actually, because I saw her use the pestle kind of analysis with regards to waste management, which is good. It's very refreshing to see, because we're looking at waste, as she put it, as not being a waste, but an unspent or an underutilized resource. High generation, she spoke about the food waste, and it's quite surprising actually, the waste numbers that she was talking about in terms of what's happening, obviously in the Kingdom of Bahrain. But obviously she demonstrated that there's good feasibility for using this kind of waste, and so that was very good. Then we went through, and she spoke about obviously the hierarchy of waste, and spoke about her own study, which she showed to be very promising with regards to using food waste to sort of generate good returns on investment. Then we had Mr. Amjad from IRENA, who spoke about dynamic transition. He spoke a lot about renewable energy and what's happening in terms of the changes that are happening. He also did speak about what happened in COP, and why it's important to continue to drive this improvement of energy. And he also mentioned on how many more jobs will also be created because of this. I spoke about the GDP boosting from renewables, also and accelerating the energy transition. So the energy transition also does need a lot of focus on that. And he said that he was happy to see that the MENA region was also becoming more and more committed to the net zero and putting net zero targets. And then he spoke about SDGs, well, at least relationship and partnership building. So I think that relates to SDG 17. And he said that he ended with saying that how IRENA will be working with COP27, 28 to try to address some of the issues that he mentioned. Then finally, we had Dr. Jing. He gave us a very nice presentation about carbon capture, utilization and storage. The good thing about this presentation, Dr. Jing, is many of the presentations I've attended with regards to this, they really do speak a lot about the technology, talk about a lot of things. But in your presentation also, what I liked is that how you showed the exact direct implementation, the successful implementation of the CCUS. So he gave us some good insights to how it works, overview, but then he spoke about some of the projects, the 2 projects that he demonstrate really good amount of carbon capture storage, and that also can also grow and in phases. And he did speak about the large opportunities there in the Middle East because of how much drilling we're doing, and obviously for various different reasons. But he said that the regulatory frameworks need to be developed, the funding frameworks, capacity building, I guess, at a local level. But there is quite a bit of knowledge already with implementing these projects around the world. And yeah, and the scale up of CCUS and CCS in this part of the world was something that he looked positively at. So I hope I've summarized the 4 presentations very quickly for you all. So I have not seen any questions come in right now from the audience. But I would actually like to ask Dr. Sumaya, when you spoke about the kind of the waste management and the technology that you studied, did you look at the impact of the investment into actually then using this food waste in order to generate energy? Because most people will tell you that the calorific value of organic waste is not the same as for example plastic waste. It was mentioned actually by His Excellency the Minister also this morning. So is it really feasible from an industrial scale?
Yes, thank you for your question. And actually, the study was conducted for all the biodegradable portion, or let's say organic portion, that includes even the plastic. So the plastic is considered somehow as an organic portion. So that's why maybe the calorific value was high, and the incineration as an option with heat recovery was one of the top prioritized technologies to manage waste in Bahrain, and using the state-of-the-art technology, of course. But the food waste, in terms of the food waste portion, so the anaerobic digestion was the most preferred. Actually, using some enabling policies like segregation at source, and it will not be feasible in the current status with the mixed waste status. So to ensure the quality of the outcome or the end products, we have to have the reforming the policy first. Then we have the segregation at source, and we have to have a national sustainable strategy to manage waste at first, using the prevention and reduction as a priority, using some legislations and regulations, and having some like pay as you throw policies in terms of reducing the rate of waste generated in Bahrain.
Okay, thank you. I think so. So, Mr. Amjad, just to ask you from a maybe a policy perspective, is IRENA looking at waste to energy as something which is an area that IRENA looks at, or sees that as outside its scope?
No. We're not wedded to any form of renewables. We see the bioenergy, the waste energy is one of them. And then indeed, we have had the experience of, in fact, through the former IRENA ADFB facility, established 2 facilities. One was in the Maldives and one from Antigua and Barbuda. These are rather small scale, but I think this is something that we learn a great deal of things from policy, regulatory implementation. I think IRENA's focus is not limited, and we are very much into it. I think that's why I was very eager to hear from Dr. Sumaya. I think it's very interesting. I'm sure, IRENA could learn from those as well. And we are very much, expanding to that area. Yes. Yeah.
So, Mr. Mohammed, I want to ask you, because you're working on this project, the expansion project in terms of the refinery. Are you guys in Babco also implementing anything with regards to renewables as part of this, as part of the new project?
In terms of the new project, not really, to be frank. Mainly in terms of environmental issues, the two things which are being focused on right now is efficiency, number one, okay, making sure that the units are as efficient as possible. And number two, in terms of environmental impacts, the air quality emissions, making sure that despite us doubling our capacity, we're actually reducing the vast majority of pollutants which are emitted to air. But in terms of renewables, no, that would be considered something separate from the current major expansion project. So this will enable the company to, let's say, expand its reach and perhaps invest in the future. But currently, the project itself is expanding the current POPCO facility rather than incorporating renewables.
Okay, thank you, Mr. Mohammed. So, Dr. Jeng, we have a question here on the Canadian CCS. You referred to the saline aquifer and 25-year project life. What happens after this, and what is the permanent chemical end state of the CO2? And what does this? How does this compare to the chemical and end state permanency of CO2 injected into the oil wells? So a bit of a technical question there from Roger. You're muted, Doctor.
Thanks, Dr. Wada, and thanks for the question. Yeah, indeed, a very good question. Yeah, so project design life is 25, but the storage capacity is much more than the number we quoted for the initial phase. And this is the saline aquifer with a well-characterized storage capacity as well as a cap rock capacity to really store the CO2 for a much longer term than the project life, much longer term required. The advantage, of course, with a saline aquifer is you do not have many old well, negative well penetrations. So the risk of leakage by wells is much smaller. But you do need to understand the geology, the cap rock, and there's a seal over in terms of geomechanics, in terms of thickness and strength. But it is properly done. It is all investigated. There's abundance of data. So that is a very successful project with the required MMV in place, which is measurement, monitoring, and verification, which is necessary for you to get a permit to meet the regulatory requirement, local requirement. So okay, yes, that is it's a good project, and the oil and gas project, I can, if I have time to talk about, there is advantages and disadvantages, of course, in a mature oil fields. Sorry,
so there's another question on the complexities associated with transporting the CO2 in pipelines, and particularly in mixing different streams with different impurity levels. And what are the broad possibilities for offshore CO2 storage, and will it only be used for when conditions are sort of more perfect, as Glenn, who asked the question, says?
Yeah. Again, good question. Indeed, they are already quite extensive pipelines of CO2 running in the world. If you look at the US alone, transporting CO2 to West Texas oil field, which we shall also have the opportunity to develop the CO2 EWAR project. So a lot of experience transporting CO2, and there is, of course, the HSE aspect in terms of make sure that you have integrity of your processes, and in leakage you could experience quite a low temperature due to the Joule-Thomson effect, and that could cause quite a bit of metallic effect. But there's nothing, there is no showstoppers. Proper engineering, proper design, proper monitoring, and all the skills and experience are in place for onshore. And so no reason for offshore deployment. In fact, the Northern Light from the onshore terminal to the subsea injection point is via pipeline, and in terms of metallurgy, in terms of design, in terms of monitoring, the whole details are all in place to make sure that we meet the requirement and we meet the engineering design standard. So yeah, so it is a good question, but there is no issue, and it can be done. It's being done. It has been done.
Okay, thank you very much. Okay, so I'll because I'm cautious of time, but this is a very nice question from Mark Skellen, and what I'm going to do is ask this question, and I'd like all the panelists to give their sort of 1 minute feedback and closing remarks based on this. So Mark says here, thanks for the panelists' insights. I've heard a strategy for decarbonization of the energy system to electrify everything that can be electrified, source electricity from the technology as far as possible, use CCUS with fossil fuel production and backup electricity demand with H2 and other energy storage means. So do the panelists agree to or have any kind of different views from that quick summary? And I'll start with Mohammed, and we'll go as the presentations went. And if you can give your concluding remarks at the same time, please. Mohammed, go ahead, please.
From a technological perspective, I agree. It will be a multifaceted, let's say, transition phase within the next coming 30 or 40 years, however long it takes for us to transition to a renewable energy system. With that being stated, the current, our current most optimistic estimates for where the world will be if we implement everything that is currently in place is 1.8 degrees. With 1.8 degrees of warming, we're still looking at quite substantial climate change impacts. Yes, it's not as bad as 2 degrees, but the effects are still substantial on human society. So we need a comprehensive methodology. In terms of technology, the technology is catching up. But what is really needed is international cooperation to make sure that all national plans meet the international agenda. That means making sure that countries who are the largest emitters do end up putting, and largest emitters and largest historical emitters as well, do end up placing policies which will reduce their emissions more drastically, and also allow developing nations the capacity to build their countries at the same pace as previous as developed countries had done previously. So I think it's not really a technologies issue, more of a policy issue. The technology is catching up. Economies of scale will kick in once this technology is ramped up. But the ultimate question is, number one, investments. Number two, are countries willing to cooperate in order to ensure that everything that we do matches up with a 1.5 degree warmer world? Or are we going to continue down the trajectory which we're currently going on, which is not much cooperation, which has led to now 2 different SDG periods, one in 2015 and one in 2021, in which all of the world's goals simply don't meet where we need to be. Thank you.
Right. Okay, thank you so much, Mohammed. Thank you so much. Dr. Sumaya, if I can ask you to give your comments on that in your closing remarks.
Yes, thank you, Dr. Allah, and thanks to Mark Scanlon for the interesting question. Actually, as a response to the maybe COP26 conference of parties towards the impacts of climate change. So all the countries in the world, or as a global response, should be committed to reduce the greenhouse gases and the impacts of climate change. In terms of complying with this initiative, all sectors should have some steps towards achieving this goal through having renewable alternatives or sustainable alternatives within their entities, or even within the industries. Actually, as I have mentioned, that waste to energy, especially the thermal conversion technologies, are very feasible for Bahrain, especially having maybe heat recovery, optimizing the energy efficiency as well within the facilities, within the power plants, in terms of reducing the greenhouse gases, using an adoption of the green technologies like incineration, pyrolysis, and gasification. They are very promising to have the syngas for example, that is producing the hydrogen as a source of energy rather than the natural gas, which is considered a clean resource, and even having many alternatives in terms of even focusing on the biodegradable waste, for example, using the co-digestion technology, for example, within even the wastewater treatment plants to operate the facility itself, rather than using the fossil fuel. So it is very promising, and by overcoming the barriers, of course. And of course, we have to have a policy, a supportive policy and regulation to support these practices. And of course, it is we are supporting your thoughts. Yes, we agree with you, Mark. Thank you.
Thank you, Dr. Sumaya. Thank you very much for your participation. Mr. Amjad, could I ask you for your closing thoughts and reflections on what Mark said?
Yeah, thank you very much. I just wanted to reiterate, yes, what Mark said was indeed correct. The electrification, energy efficiency, green hydrogen, bioenergy combined with carbon capture and storage. I mean, there's no way that these can be eliminated part of the solutions. It is part of the solution. So the technological revolutions are happening. And I think it's inevitable that we have to align with the 1.5 degree world. We cannot afford, because I don't need to repeat again, like, there's a considerable amount of disasters happening. It is evident that, climate is happening. And again, we need to get the technologies, markets, and business models continuously evolving, and then being able to apply these to target policies and measures for a 1.5 degree world. I just wanted to also indicate the recent developments with IRENA and UAE, which we have launched, the Energy Transition Accelerator Financing Platform, a climate financing initiative that will mobilize US $1 billion in renewable energy financing by 2030 to support 15,000 megawatt of renewable energy projects that are directly linked to NDC implementation. Obviously, ETAP offers a broad range of financial products and innovative financing solutions, financing matchmaking of renewable energy projects, which will obviously be subject to funding partners, compliance with procedures and due diligence in line with credit financing or investment requirements. Obviously, IRENA will offer technical assistance and project facilitation, which we have the comparative advantage. In addition, we plan to continue working with partners and financiers to channel financing for a pipeline of renewable energy projects to support implementation of ambitious NDCs. Simply for the 1.5 degree goal of the Paris Agreement, and mobilize financial resources for international financial institutions that would provide climate finance to multilateral development banks, global, regional, local banks. And again, to facilitate the financing matchmaking of near-ready renewable energy projects. Again, just reiterate, I think it's inevitable that we have to move to the 1.5 degree world. Again, we are not excluding any options, recognizing that, the renewables are on top of that. Thank you.
Thank you very much, Mr. Amjad, for your participation, for IRENA also. And finally, Dr. Jing, your views on this. I know you gave your presentation on CCUS and all that, but yeah. I mean, generally more holistic, probably summary to your views on these areas all collaborating with each other.
Yeah, thanks. I agree with Mark's question and echo many of the good points already being made by fellow panelists. I think we need all the solutions that has been put on the table. Need technology enablers, need commercial framework, need a regulatory framework to make things happen. It's an energy transition. It's not a choice of either or. It is really try to embrace all the solutions we can find practical in our toolbox. So I mentioned a specific example of CCUS. I think we have the opportunity to combine carbon storage with continuing hydrocarbon production, but at reduced greenhouse gas emissions, because you can produce oil, then you can transform your mature oil and gas fields into a CO2 store. And that is cost effective, and you have a lot of enablers, advantages compared with a green field. So yes, just to re-emphasize that I see great opportunities in the MENA region to do that. A lot of work need to happen, collaborations need to take place, and partnerships need to be in place. But I'm optimistic. I think that will play an important role in reducing carbon intensity and in our pathway towards a cleaner, much cleaner energy future. And that is my take.
Well, thank you, thank you to all our panelists, Mohammed Ghassan from BAPCO, Dr. Sumaya Yusuf from the university, Amjad from IRENA, and Dr. Jing from Shell. And for me, it's been quite an interesting discussion. If I give my just final reflection on this, as Dr. Sumaya was explaining how actually the organic waste actually included the bottles, and I was thinking from a business perspective, when you do the waste characterization, and you're thinking, well, okay, so that's why the calorific value of the food increases. We realized that also there was a policy, and this is just directly to speak to Mark's point here, that there was a policy passed a few months ago in the Kingdom of Bahrain to stop using plastic and plastic bottles. So the waste characterization moving forward would change, and that would impact on the calorific value. Anyway, I mean, that is for a different discussion, but that is probably why I think, from my reflection, that back to Mark's sort of question, yes, you can look at decarbonization, look at electrification, you can look at using technology and moving into H2 and things like that. But if these thoughts and these things don't work sort of collaboratively, and the policies sort of driving the right kind of behavior, Amjad spoke about a fund, and the fund will obviously attract people who want to use this fund, because they'll find it as an opportunity to spin off and sort of create some startups and some businesses and stuff like that. And so we have to be very careful, and I think governments have to be very, very careful, working hand in hand with academia, with the private sector, with the innovators, and people want to look at the startups and the public, really, in terms of their behavior, because it all needs to work together to get that perfect mix to create the I look at it and to use a chemical or a chemistry term, the stoichiometric mix that we require in order to get the best for the future in terms of doing these things. Because if we're changing policies in different areas, we're driving different things, and there may be developments in technology faster than the uptake, or not enough electrification that is required, and a reduction in oil and gas, which can cause an overall energy price rise, which is going to be detrimental to GDP growth and employment and other social issues. So it really is a very, very complex and world which is becoming more and more complex. And I think that the only way is to sort of communicate and collaborate with each other in all the corners of industry and academia and policymakers to bring this thing together. And with that thought, I would like to, on behalf of the Energy Institute, once again thank all the panelists. Also thank His Excellency for addressing this morning. Also Mr. Mustafa and his panelists also for their discussion this morning. This brings the sort of the conference to an end. There's going to be around about a 70-minute break now, and then 11 o'clock GMT, which will be 3 o'clock Dubai time, and 2 o'clock Bahrain time. There will be a workshop on exploring opportunities and challenges for the refining industry for the transition towards a low CO2 intensive economy roundtable as well. So please join that if you can. That will be, again, 3 o'clock Dubai time, 11 o'clock GMT, 2 o'clock Bahrain time. Once again, from me, it's been a pleasure and a real honor being here and speaking with you this morning. And wishing you all the best, safe safe safety ahead, and take care of yourselves. Okay, and again, I'd like to also thank Francisca and the team who have been behind the scenes in the EI live event, sort of managing here today. So thank you very much again. Salam alaikum and God bless. Take care.
Thank you.
Thank you.
Thank you very much. Bye-bye.
شكرا دكتور.
Thank you very much.
الله يحفظكم. شرفنا حياكم.